Hello, everybody, and thanks for coming along. So today in a talk, we'd just like to explain a little about the CERN container use cases. My name's Tim Bell.
I'm Spiros. I was the Magnum PTL until recently, and for 4 cycles.
So if you're ever driving from Geneva to the Jura Mountains, you might notice this strange Christmas pudding kind of object on the right just as you cross the border. That's one of the CERN exhibition centers. And behind that, you can see the Atlas experiment. Well, the surface buildings of the Atlas experiment, it's 100 meters underground. So CERN itself, it's a multinational organization. We're now 23 member states. Serbia joined in the past month. And the budget's around $1 billion in order to investigate fundamental science, what the universe is made of, how it works. That's about a cappuccino for each person in the member states that contributes per year. So it's a reasonable deal. The actual CERN Accelerator complex, it's more than just the Large Hadron Collider, which is the 27-kilometer ring. There are actually around 50 experiments at CERN, everything from doing antimatter studies to working with the space station to do detection of cosmic rays from space. So as part of that, we basically accelerate a set of protons around through the accelerator complex until eventually we collide them in 4 places around the ring. The biggest experiments, Atlas and CMS, were the 2 experiments that together combined to discover the Higgs boson that gives us mass. And that was the Nobel Prize winning award for 2012. So we use OpenStack very heavily. Around 90% of the compute infrastructure at CERN is currently based and running on top of OpenStack. We've been running, I think the first installations were about 2011. It was kind of early days. Production in 2013. And then since then, we've been doing incremental releases. And no virtual machines or resources have been decommissioned as part of that. It's simply been a question of evolving the cloud. The evolution has been very much a question of starting off with the basic functionality as was available at the time, Keystone, Nova, and then building out from that. And this has been adding additional projects as we went along. And in particular, one of the projects that we'll talk about today is Magnum, which was brought in around the Liberty cycle as a pilot project, and then went into production at CERN. All of these, we have the approach of taking everything and contributing upstream. So that means that things that we do that are of any use to the rest of the community will be things that get included into the open source version. So I'll hand over to Spiros to give you the details on the CERN container service.
Hello from me again. I will talk to you about the CERN container service, some of the use cases we have at CERN that are not exactly running, they're not run by us, but our team provides the infrastructure to other groups and physicists to run analysis and do traditional IT. And then I will talk a bit about the upstream project and all the features that we develop at CERN, but we directly contribute them back to the community. So this is the overview of the OpenStack infrastructure. We have around 300,000 cores. And we create more than 200 VMs per hour. We have 35,000 VMs running at any time in the cloud. And we're around 500 more or less clusters running. They increase and decrease, they fluctuate a lot. And we have around 2,000 nodes of Magnum nodes that run mostly Kubernetes and some Docker Swarm. So this is what a piece of the Magnum dashboard looks like. I think yesterday we had a bit more than 500 clusters, like 550. Then some teams deleted a lot of them, so we dropped again. But as you can see, most of them are Kubernetes. And the swarm number that you can see, 140, actually, it doesn't say the complete truth, because there is one team that has many, many small clusters. But if we spread around how many teams use what, most of the users use Kubernetes. As most components of our cloud, we run the Rocky release. And for Magnum, we carry a couple of patches to adapt to the CERN network that we have, because Our data center is a very old data center that evolved gradually, and some changes had to be made, not only in Magnum, in Neutron, and in Nova as well. We are also adding some custom storage features like EOS, which I'll mention later, which is for physics data, or CVMFS, which is for distributing high-energy physics software. Also, some other small details is to integrate with our central monitoring system and to add the identity to all the nodes, to issue certificates and host GitHubs. Regarding the storage integration, this was done by Robert Vasek. He was a trainee for 1 year in our team, and he did a very impressive work regarding CephFS and Manila. All this work was done from the beginning upstream. So you can, if you use Manila with CephFS, you can use exactly the same configuration as we are using. This work was twofold. One was the CSI driver for CephFS, so that Kubernetes would interact directly with CephFS and mount shares. And the other was the Manila provisioner, where users could declare a storage class and then create dynamically shares in Manila, and Manila would carve them out of Ceph. And then the attacher of CSI CephFS would take over again and mount appropriately to pods. Similar to CSI CephFS, Robert, with help of Ricardo, continued working on CVMFS, which stands for CERN VM file system. Again, this is available. CVMFS is appealing for a couple of users outside the high-energy physics world. So it might be useful for you if you want to distribute hierarchical software or other kinds of data. And this is a read-only file system that works in the same way as CSI CephFS. And you can mount specific repositories of software in pods. Then there was EOS, which is the most important integration regarding physics data. This is an in-house open source, though, file system that others can use as well, where we have around 200 petabytes of data. And this is not a CSI plugin. It uses a daemon set on all nodes and mounts directly from EOS data to the pods and volumes. And then now we'll talk about some of the use cases. All the integration that we mentioned above was required either to run Magnum in our cloud or to be useful for users, because just running Kubernetes and not having access to data, it wouldn't be very useful for them. So the main business of the data center is batch processing. There is a batch team in our department that runs a batch system, which is called HT Condor, and users from the high-energy physics community submit jobs and so on. There are also other use cases where users want to do interactive analysis on their browser without having to install anything, just Chrome or Firefox or others. And there are teams exploring these solutions to run with the Project Jupyter interactively and benefit with all the integration and storage that we have done, and give easy access to data for users. In the same context, machine learning can be used with TensorFlow and or Keras, and we're starting investigating also on GPUs that might be of use. And apart from the physics analysis, there is also traditional IT. We're a big organization, and we have a lot of traditional needs like CI/CD or web servers or other kinds of platforms. And of course, we started also to investigate on running OpenStack with OpenStack Helm or just by hand. I mean, writing our own manifests. The first use case comes from the analytics working group, which is a blend between the DB and the storage group at CERN. So they are investigating how to use, they're stopped investigating, they're just using it now to run Spark on top of Kubernetes. And the upstream community has created the Spark operator. An operator is a paradigm of how to run an application in Kubernetes. And they have integrated again with EOS and other in two ways, benefiting from our integration, but also talking directly with a dedicated client to EOS. So what they're doing, they create on the Magnum service Kubernetes clusters, and that they are targeting either for specific people that want to do a short living analysis for 2 weeks, or they may run bigger clusters that are longer living, and they give access to multiple users. All this work is again upstream. They work directly with the community for running Spark on Kubernetes, apart from some certain specific bits which are necessary for talking to our special storage systems. Then a very impressive one is the Rihanna and Recast project. This is a project that physicists can run workflows that are comprised by Kubernetes jobs. So this is not using any kind of CRDs. It's just a big manifest. Every job is a big manifest that it's comprised by different jobs that points to different Git repositories with specific workflows, and they run. They can run different steps, either in a very parallel fashion or just pipelining. This is also very close work with the data preservation and reusable data work that is happening at CERN, where if a physicist has run an analysis with a specific set of data and has some specific results, they want to find a way to have this analysis reproducible. In the past, that wasn't very obviously how to do it, but with containers and the declarative way of using and describing Kubernetes applications, it's much easier and better, at least for younger members, it's much more obvious how to work on it. This was done by the Invenia user group and the Atlas experiment. This is closer to our team. It's actually within our group, where the batch team is investigating how to run their batch system on top of Kubernetes, and to benefit from the monitoring that Kubernetes gives almost for free for standard metrics like CPU memory and so on, but also to have a declarative way to deploy in our cloud, which we use standard upstream Kubernetes, but also to public clouds. If they want to buy, for example, clusters in the Google Compute Engine or in AWS or in Azure, it's the same interface. They're mostly working on how to iterate, to transform their workflows that they usually use with Puppet, how to transform them to be Helm charts and or Kubernetes manifests. This ties very close to the previous example that I mentioned. This is to run again batch, but in a federated fashion with Kubernetes. There was a very interesting talk and that was done last year by Ricardo and a student that we had working with us, how to federate a lot of Kubernetes clusters in different clouds and create a very big batch farm. This was done using Kubernetes Federation version 1, and now we are working, there are two members in our team, Ricardo and Thomas, that are working in Federation version 2, which is just getting stable in the Kubernetes community. So in this experiment, they tried to federate, actually they successfully federated 7 different clouds, and they ran some analysis in all of them. I have 2 more, so now we're going more into traditional IT. So this is the WebLogic on Kubernetes project that was done by the DB group. So they are using the service. This is actually the most cloud-native way, I would say, to use Kubernetes in our department. They have started from scratch developing the application. They moved all the Oracle components that they have in pods, and they benefit from all the modern cloud-native monitoring systems like Telegraph and so on to monitor and iterate on their application. They're deploying for HAE 3 clusters in the 3 availability zones that we provide them. And they maintain their own Helm charts recently, and they started with standard manifests, and now they're moving as well to Helm. And they're actually the first user to leverage the keystone authentication to have a multi-tenant access to when managing their application. In their use case, it's not that they provide a service, but they have people managing the service with different roles. For example, there are some admins, and then there are some other users that they want to do only small tasks like deleting a pod or seeing the logs of a pod. This is the file and newest investigation from our department. It comes from the CDA group. And they're investigating on an alternative for the mail service that we currently have using the Copano project. They're investigating different ways to deploy the application. So this application has the backend, which is the mail servers, and the front end, which is the web application, and some intermediate components like memcached. So they're investigating running only one big Kubernetes cluster that runs all their components, or running small clusters per component to have resiliency. And they're also investigating having HAVMs with Masakari. I think the single Kubernetes cluster is winning for them because of the easiest way to iterate on it and the faster failover that they can achieve or scale up or scale down. Now we'll pass to OpenStack Magnum because in our team we have 4 or 5 people. We don't want 100% only in the Magnum project, but they're focusing a lot on it. So the features that we develop at CERN actually are upstream features, so this might be close to a project update, but this is what comes from our team. So very fast, I would pass the slides that usually I carry. What is Magnum? Magnum, if you don't know, is a small OpenStack API service that it has an API in the conductor that you submit a request to create clusters on the API. And then you as a user, you're the single tenant of the cluster, which runs on your own VMs. So isolation is strong between using VMs or physical machines. And then there are more advanced features like Multimaster and a big list of add-ons that we implement and users can enable or disable. In the past, I had this slide with all the logos on the same size, but clearly Kubernetes is the biggest logo at the moment, with Docker Swarm following, and this US, at least in our usability user base from our project, is declining very fast. So what is a Magnum cluster? A Magnum cluster actually is like a meta resource. What it really is compute instances, so Nova and Ironic, neutron networks, security groups, neutron volumes in Cinder or Manila, and load balancers in Octavia. All this is orchestrated by HIT or the cloud provider in the case of Kubernetes. But what Magnum does is interacting with HIT and then subsequently with all the other OpenStack services to scale up, down, autoscale, upgrade, or heal or replace nodes. Each cluster is a very self-contained resource that has everything inside, monitoring, data store. It doesn't depend on any external components. So how working with Magnum looks like. So typically a cluster operator, in our case the cloud team of CERN, provides a set of cluster templates that users can consume. For example, here we have Kubernetes HA and just Kubernetes. This is actually not true because we are now moving towards having Kubernetes dash some version to be more understandable for users what to use, and always the highest version is what they should go for. Then the user picks a Kubernetes or a cluster template and creates a cluster, and a few minutes later, recently it dropped again to 5 minutes, they can have a cluster up and running. This is true for either 3 nodes or 500 nodes. Like the deployment time is more or less the same because everything is parallelized. All nodes are getting configured in parallel. Then the strongest benefit of Magnum is that with one more API call, you can get credentials for the cluster. Recently, we added also keystone credentials, as you can see with a -- use keystone parameter that configures the kubeconfig file. This is true, of course, only for Kubernetes. And then using the webhook for keystone, users issue tokens, and then they can talk to Kubernetes with that token. This is an excellent paradigm if you want to rotate credentials. So if a member leaves the organization, you just revoke the OpenStack account, and then that person loses access to the Kubernetes cluster. Of course, if he had if they have created Kubernetes tokens or certificates that Kubernetes provides, this must be revoked inside the cluster. So why we use Magnum and why someone else should use Magnum? It's a centrally managed service, and it's a self-service, so we don't receive tickets or, well, when something broken we do, but we don't receive tickets to create a cluster. It's completely self-service. So if you have groups that you want to offer to them clusters, it's an excellent option. If you have 5 users and you have like less than 10 clusters that you can actually name, maybe Magnum is not very flexible for you. But again, if you deploy OpenStack with a standard tool, it's very easy to have access to it. Also, since it's an OpenStack service, accounting comes for free. You don't have to do extra accounting because users will be charged for cores or RAM. And what is actually very useful as well is a very easy entry point for new users. For example, for Kubernetes, Minikube is another option, but that requires some plumbing on your laptop, install KVM or VirtualBox or whatever. In a service like this, they can get very easily access to the Kubernetes API and start developing applications. So a large amount of the clusters that I showed before, it's mostly small clusters that users develop on them and they iterate very fast. Or even use it as CI/CD. Just create a cluster, run the application, and then delete the cluster again. Some notes on what to consider because it's not obvious what to do from the beginning. This is also was very tricky for me as a PTL to describe what are the requirements of Magnum. And I was saying you must understand how the cloud works and be sure that the networking is configured properly. And when you create VMs with Heat and then, of course, via Magnum, these VMs would be able to access the OpenStack APIs. This is not an easy thing to understand for newcomers to OpenStack. And then the operators of the cloud must communicate to users what to use and what is the SLA of the service. Like if you have a very critical service, you must go for Multimaster, or you must have persistent data for the data store of Kubernetes, or even for Docker Swarm. Then what is very important is to run a container registry. This is like a recommendation for any container workflows that you must, usually you should rebuild your containers locally. You should not download images from Docker Hub blindly. For example, the Magnum team has an account in Docker Hub, and recently there was a hack from on Docker Hub that almost 200,000 accounts were leaked. So we had to rotate passwords. So this is something that you as an operator cannot control very easily. So it's better to run your own registry, rebuild the containers with all the Docker files that we provide, and run everything locally. It's more performant, it's more secure. And then you must always keep in mind that since you provide, like in OpenStack with images and containers, you provide indirectly software to users, so the same workflows should apply when to upgrade the baseline operating system, Docker or Kubernetes or Mesos if you use it. And now a few words for the new upstream features that we have implemented in our team. This is half implemented in our team. It was with great help from Phelan, which is the new PTL of Magnum for the train release. What came up many times from users is that they wanted to delete a specific node, and until recently that wasn't possible. They could only just decrease the node count of the cluster. So now they can target with the UUID or the index of the node which node they want to remove, and Magnum will take care of it. This is released in Stein, and it's already available, and it's compatible with most of the old clusters. As I say, it has forward compatibility. How this works, so you do just COE cluster resize, you pass a node group, and that will mention later what it is, but if you run a cloud that even that hasn't deployed the new versions of the drivers that we implement that support node groups, Magnum will just use the default node group, which is the worker one, and then you can say that I want to delete, I want to decrease or increase to node count 3, and in the second example, you will just pass the Nova UUID, and then Magnum will take care of deleting that node. The second feature that was implemented in our team, it's node groups, and most of the implementation was done by Theodoros, and the design was done by me and him, and the interaction with the community. It's to have heterogeneous clusters, meaning spread in different availability zones with different flavors. For example, some workers to be physical, some workers have or not having GPUs. And if you have more advanced configuration in your cloud with host aggregates, you can play with more flavors. This is implemented as an API so far, and we're working on having the first driver that supports it. It's not merged yet, but it will be in the first release candidate for train, so maybe in 1 month or 2. So how does interaction with Magnum would look like? So users who do OpenStack COE node group list, and they will pass the name, and they will see how many node groups they have. So if you run Stein, you will see this. You won't be able to interact exactly with the node groups, but you will already see that the structure has already transformed. And then, as you can see, when you do show of a node group, you can see that it has a flavor, which is per node group, and the output like the IPs, and of course it has a role that this is the master node group. And initially we will have only master and worker, but then we will add also etcd as well. Another feature that I already mentioned was keystone authentication. This was a requirement from our team and many other clouds because it's very hard to rotate TLS certificates, and it might be catastrophic for the cluster if you don't do it properly, or it will introduce downtime. While with Keystone, it's very easy to just revoke the access, revoke the tokens, and Kubernetes will stop giving access to users. I already described the workflow, but you can see it here again. Then this work was done in our team with a lot of help from Blizzard and Catalyst Cloud in reviewing, and the Google team that they are the maintainers of the autoscaler of Kubernetes. So this was done all working the Kubernetes / autoscaler repo, adding Magnum as a cloud provider. It's not an OpenStack cloud provider, it's just for Magnum that implements the interface of autoscaler. It receives information for metrics like CPU, memory, and network from Kubernetes that they come for free, and decides when to scale up or down. It's possible to add custom metrics like latency of the application or request per second, and scale up and down as needed. In the Stein release, we also have added a flag to enable or disable this feature, so the autoscaler is getting deployed by Magnum, and you don't have to do anything else, just pick the right label. Also, a contribution from our team was integrate the Prometheus operator, the upstream Prometheus operator from the official Helm chart. And so this is again done with a flag that deploys the Prometheus operator, which is a very slightly complicated setup with Prometheus and Grafana and a node exporter to monitor all the nodes, and with also integration for the metric server, which is the new way of Kubernetes to collect metrics. So at least at CERN, we will work on a 2-week retention for data, but this is customizable, and users of the cluster can configure them as they want. This is what I'm working on personally, and with a lot of help with Feilong in reviewing, which is upgrading Kubernetes and the underlying nodes. What we have achieved so far is in-place upgrades, meaning only Kubernetes will be swapped. The version will swap to a newer version. And we're working for worker nodes. And we're working also in the node replacement, which will we will backport actually to Stein and release in train RC1. And we will do like a major, not major, but not a point release in Stein. It will be like, I think, a 9.1 or something like that. This will not be forward compatible, meaning old clusters will not be able to upgrade. Only new clusters will benefit from this functionality. And then a couple of more add-ons. We started having traffic as the only English controller available since the Queen's release. And now we have added as well, we bumped the version of traffic. We also added the Octavia load balancer, the Octavia English controller. And what I'm missing here also Nginx, which is also available in Stein. So this is very useful if you want to do TLS pass-through, or if you want to expose non-standard ports, like, I don't know, port 993, which the Copano team is using for IMAP. We also have added the node problem detector, which is customizable for custom features like the storage systems that we have. We will try to implement something for Manila as well. So if you run the Manila provisioner or CSI FFS, it will detect if the add-on has an issue. For example, I don't know, it receives 400s or 500s from Manila or from Keystone because the account expired or something like that. And the final item that we're working is the pod security policy. By default, Kubernetes is more like a platform that you should develop on top of it, and pod security policy by default is very, let's say, permissive. So we are working on having two modes, one strict and one privileged. And of course, we will have enable restricted by default. Some conclusions based on feedback from the Magnum community and the CERN Cloud is that we use Magnum because we have very diverse workloads. For example, compute-intensive workloads cannot coexist in the same Kubernetes cluster as a service that runs mail or some other accounting system, because the compute-intensive workload might interfere not only in the workers, but also in the control plane and hit hard the control plane. And we have very different teams with different purposes, so we don't want to go directly to the rabbit hole of multi-tenancy and Kubernetes. Although we are starting to investigate that direction, but having isolated clusters with separate control planes, it's a better fail-safe. If you have questions about Magnum or even the CERN use case, you can hit us in the OpenStack Discuss mailing list or in IRC. And that's it. If you have any questions, otherwise, thank you. Any questions? Yes.
Did you ever consider to use cluster API?
I will repeat the question. So the question was if we ever considered using the cluster API to deploy Kubernetes. Yes, of course, we have considered it, and we are already investigating how to leverage it. But we didn't jump immediately on it because we waited a bit more to get mature. And since we were already in a point where Magnum was stable using Hit, we didn't want to jump immediately. But yes, we are investigating it. We will try to use it as soon as possible. Yes.
How many public clusters and templates do you have embedded in your infrastructure?
Sorry, say again?
How many public cluster templates?
Public cluster. So the question was how many public cluster templates that we have. At the moment, they are around 8, I think. 6 are for Kubernetes for different versions. And 2 of the 6 were the previous model that we had the Kubernetes stable and a Kubernetes beta. But adding new versions, it will the number of cluster templates increases. However, we added a new field that I failed to mention. I will mention it maybe tomorrow in the project update. Is the hidden field on cluster templates. So to not make an explosion of cluster templates, operators can mark templates as hidden. Users can still reference them with the UUID, but they cannot list them, so it avoids confusion for new users. It's similar what Glance does with the community visibility. You can access it, but you cannot list it.
Did you manage to have GPUs in your container in a non-active way?
Yes, so we managed to, the question was if we managed to have GPUs in Kubernetes. The answer is yes, with the Kubernetes NVIDIA device plugin. So without doing any modifications in the operating system on the host, we just added a daemon set with a device plugin, and Kubernetes was able to expose GPUs, and users can request GPUs in the resource request section of the manifest. Yes.
Is all your Kubernetes clusters on OpenStack instances or on bare metal?
Most of them are in VMs, and actually in our team, in the OpenStack Cloud, we are mostly in favor of virtual machines. But users, especially the batch team that are compute-intensive workloads, they're investigating physical machines. The workflow from their point of view is exactly the same. They just change the flavor to point to a flavor that maps to an ironic delivery that we have in our data center, and they can just go for it. But for other applications that they don't need it, we advise them to go for VMs because VMs are faster to spawn. And if you don't need the last 3% or 2% or 5% of performance, VMs are more agile. But yes, support is the same for both. Yes?
How do you manage your data flow, and do you have problems when many users are trying to access the data?
You mean for the physics data that we have? The data flow, so the experiments have the first level trigger farms. Okay, I will go faster. So the accelerator generates data, and data after some steps of processing ends up in our data center, where most data are available with EOS. So we have the accounting system based on LDAP in our organization, and users with their credentials using Kerberos access physics data in EOS. Which is for physics data. We also expose the Rados gateway for S3 access, so there they use the OpenStack credentials for it. We didn't have any issues with that. It's just the accounting in the physics data comes from LDAP, and the accounting for data in S3 comes from OpenStack. Okay. Yes. Yes, so we had added all the cluster configuration for add-ons in the master deployment. So in the past, before starting spawning worker nodes, the HIT was first configuring and deploying the master nodes with all the add-ons, and then the boot of minions were starting. But now the boot starts immediately of all nodes. They're installing Kubernetes in parallel, and when the master is ready, they just join. They're in an active loop trying to contact the master, but as soon as it's available, they join the cluster. We backported to Rocky as well. Yes, and maybe, and Queens. Stack HPC, they want it in Queens. We have also backported in Queens. Cheers. Thank you.